All right, so just want to take 1 second before we get Matt on here to talk about one of our other gold sponsors, Linode. I use them personally for a lot of production things, including Laracon.net. Use them for at least a decade, maybe even more, pretty much since I started. And really great service, really fast servers, very affordable, obviously. They've also added a lot of new things lately with dedicated CPU and various other handy little things they've added over time. So definitely check out Linode. In Digital Swag Bag is $20 credit, so you can spin up a 1 gig server and run that for 4 months, put side projects on there or use it for a production app or whatever you need. Give that a shot, super easy to scale. They have a new backend console that's a lot nicer and also works with Forge perfectly. So give that a shot. Definitely highly recommend Linode and check them out. All right. Now, bring in lots of mats in here. Look at all these mats. Literally a page of mats. I think I got the right one. There he is. Oh, unmute, unmute.
There we go. Hey, buddy.
There he is.
Just like Taylor said, it feels like it's just me and you. There's nobody else.
I know, that's what's beautiful about this. We need to do, maybe next year we'll have like a fireside chat or something. We need some kind of like just a little
concept of the people that are. You know what I like is like if we could like build something where every person who's there is just like a little pixel and you can kind of see them like
that would be interesting because everybody does have that same kind of, you know, when I talk to even people watching don't know, but we go through like a little text setup with each of the speakers and everybody's like, you know, expresses that concern that you can't see the audience. So it's definitely a different vibe. So some type of, representation of the audience would be kind of cool, I guess.
For sure.
Maybe we'll work on that for next year. I could do some kind of, I have this green screen here. Maybe I could just
yes. Just take a picture at like Laracon US or something like that and just throw it behind you in the green screen. Keep it open the whole time.
Right.
I like this.
Get a laugh track going.
There you go.
All right. Well, you know what you're doing, so I'm going to let you take it away.
All right. Thanks, Ian. All right. Hey, peeps. So I see a green rectangle here, so that means I hope that you all are actually seeing this. So if you're not seeing it, somebody from Titan call my phone.
All right. You look good. You look good.
Okay, good. Thanks. So this talk is about databases in space, and if you saw me talk about it in Twitter yesterday, this is what you're thinking. Databases rocketing through space, because that would be what would be the optimal talk to give, titled Databases in Space. Unfortunately, I'm not quite that cool, and what we're really talking about is basically space-based things with databases. So geospatial, where is the thing in space, that kind of space. Latitudes, longitudes, X, Ys, and all that kind of stuff. We'll talk about a little bit of entry-level stuff at the beginning, basic stuff that everybody can do really easily with everything you have available to you today, and then some a little bit more advanced stuff that primarily is still doable on any MySQL servers. So as always, this comes from a specific reason. So it's story time. So we have a client who comes along and says, hey, we have this app that's based on everything being geospatial. We've got, you know, points and latitudes and longitudes and all this kind of stuff, and it's almost done, but the person who was doing it before us couldn't quite finish it. Can you come in and rescue it or finish it, however you want to think about it? They said, it's almost the whole way along. We just need a few features. They described where things were and everything like that. I said, yeah, we could totally do that. And they said, have you have any experience with this geospatial stuff? And I said, no, I want to be totally honest. We're not pros at that. I'm more than happy to learn it. It sounds like there's a really tiny amount of work that needs to be done there based on what you said, so sounds good. Turns out that's not exactly where it was. And I'm not trying to shade anybody, but I want to tell you why I've ended up in this space for the last couple months. So you see those little dots, those little points in the middle of the screen? There's probably 50 times that many that should be representing. But it turns out that the code, one of the many things that I got to learn was just saying, find the center point of the map and give me the 10 that are closest to that. So that's one problem that we had there that I, you know, kind of expected it to be one way. It was a little bit different. One of the other one was every time we import new entities, it's going to figure out which of multiple regions it's within using all this complex geospatial stuff. I said, great, that's wonderful. So I opened up their importer after signing onto the project and discovered that actually it just said, all the ones that were imported on this day are from that region. All the ones imported on that day are from that region. And it turns out there was no geospatial stuff built there. And I said, oh, I didn't actually feel like I made a huge mistake because it was a fun challenge, right? But I definitely realized, well, this is going to be more of a challenge than we originally anticipated. So for the last several months, every time anybody's like, hey, what have you been working on? I've been like, geospatial, geospatial. And most of the moments I've actually looked that same way, but more like the aliens guy, where it's like, aliens, because I'm learning so many new things. And I haven't had a lot of opportunities lately to learn something entirely brand new. And so this is really cool. Like, I've literally never thought of this stuff before, and a lot of this stuff is already doable in the tools that I already use, and I didn't even know about it. So I will tell you one thing, which is that I'm just not just a slow learner. There has been a lot to learn for me over the last few months. So I'm going to present just a kind of a minimal entry point, but even what I say today might feel a little overwhelming if you've never thought about this before. The slide deck is going to be online later. There's going to be code samples online later, and this talk will be online later. So if you get stuck, you can consider this not just like a talk that teaches you everything up front, but also a reference that you can go back to later. So if you only get 1/3 of it, don't worry about it. Come back to it later. Take a look at the code. It'll be easier to grok a little bit. And before I talk any further, I want to acknowledge these three wonderful people who all have been a part of me learning. So Centauria and Sean were actually on the project with me, and some of the code that I'm going to show is their code, especially stuff that has to do with View and Google Maps. And then Logan wrote a blog post for Titan that actually helped me learn some of this stuff before I started this project. So thank you to you wonderful human beings. All right, let's talk about the basics of geospatial. So I've been using the word geospatial as a noun so far. I do geospatial, but technically it's actually an adjective that means something relating to geographic position, or maybe about how something's position relates to the Earth's surface. What you can probably infer from that is sometimes it also means how high it is above the Earth's surface, and I'm going to completely ignore that. We're only just going to be talking about where it is. But it's worth noting that that is different than geometry, which is where something is on a flat plane usually. And there's a lot of different projections. We'll talk about those in a sec, but just so you know, what we're primarily talking about here is geography on the Earth. We're going to talk about a few high-level concepts that you need to understand in terms of geography before we actually dive into the code and the practical applications. So first of all, you need to know what latitude and longitude are. So these are these lines that you can see on this map here. So the longitude lines go north and south, the latitude lines go east and west. And something you might not have noticed before, because I hadn't, is they're not actually the same shape. I always thought of them as same shape up and down, the same shape left and right. But if you look at them closely, longitude ones go to a point and a point, and so it kind of feels like they bulge in the middle, right? The distance between those longitude lines is greater at the middle, at the equator, than it is at the top. The latitude lines are relatively evenly spaced, and they go, you know, circumferentially, or whatever you would say, up, 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 up. They don't meet at points in the middle. So that's something worth noting. So the latitude lines are parallel to the equator. North means it's positive, north of the equator. South means it's negative. And then the longitude lines start at Greenwich, England at 0, and then they go negative from there, west from there, and then positive east from there. They meet up on the other side of the world. Talk about that in a second. But the center of the world, the kind of made up center of the world, is the horizontally it's the equator, and then vertically it's the line of Greenwich, England. And where they meet is actually just the middle of the ocean off the coast of Africa. And then, like I said, they go the whole way around to the other side of the world, where they meet in another line in the middle of the ocean that crosses primarily through Fiji, and that's called the antemeridian, which is usually basically where the date line is. And it's actually something people kind of talk about, where it's kind of like, hey, this is where you moved from today to yesterday. And I've always wondered about that, right? I was traveling to Australia, and I was like, am I in the past or the future? And it's kind of hard to know, and it seemed arbitrary, but it turns out basically you travel east until you hit this line, and then all of a sudden you reset back. And so that's kind of how that works. One trick that has helped me, now the trick most people use to tell you about latitude and longitude is to tell you that the longitude lines are long, but that requires you to remember that whole thing I told you about with the whole like circumferentially versus point to point, which I didn't even know before, and I usually don't remember. My stupid trick that I just made up this week is that it's the equator is a latitude line, equilateral. So the word equilateral is now just stuck in my head when I try to remember this. So that might work for you, probably not, because my brain works differently than everybody else's. But basically this is taking the sphere of our world and trying to put it flat. And again, we'll talk about projections more in a second. This is what you're looking at. So 0 and 0 are the prime meridian and the equator. You go to the far edges and you hit Fiji and kind of the date line and the antimeridian, and then look at those numbers as well. You go up to 90, down to -90, but then over to 180 and -180. Crazy, weird, and one of the hardest parts of this whole process, honestly, for me, has been remembering which one is which, and it doesn't help that different coding syntaxes use one first versus the other first. And looking at a number and knowing, that's in North America, that one is probably the latitude, and that one's probably the longitude. It's surprisingly difficult. So spending some time kind of internalizing these things will definitely help you out. 2 more slides before we get into the real code. Number 1. One of the questions I kept wanting to do as I was trying to math these things out was asking the question of, well, how far is a degree apart? Why are there not just really simple mathematical equations for that? And the thing is, it's not consistent. If you look between 0 degrees and 15 degrees there, it's 1,667 kilometers at the equator, but then close up to the North Pole, just north of Europe, it's 82 kilometers, same distance, because of those weird shapes. And so there's no one easy formula for how far is 1 degree, and so you end up basically having to rely on something not yourself, not your own math, to be able to do that calculation for you. And just a quick note, if you've ever seen older stuff that says something like 51 degrees, 28 minutes, 38 seconds north, it's just math, and there's mathematical formulas you can use to convert that into something like 51.477222. And notice that's positive 51.477222. If it was S at the end, so south, it would be negative 51.477222. Okay, cool. Last thing before we get going. There's a couple terms. Again, don't worry about these too much, but I'm going to be mentioning them later, so I just want to get them kind of primed in your brain. GIS is a geographic information system, so something that helps us think through geography in terms of our information systems. Okay. OpenGIS is an open spec. It's kind of like the FIG, the Framework Interoperability Group in the PHP world. There's this big consortium of 300 different organizations and companies that work with geospatial that all got together, and they said, let's figure out how we can make all of our systems work together. And so they released this thing called OpenGIS, like the FIG, but less drama, and for geospatial. And so a lot of these things, and the fact that a lot of these things are similar across different contexts, are because they're all applying, basically doing their work in sync with OpenGIS. ArcGIS is a very expensive piece of Windows desktop software that everybody uses. It's expensive, it's proprietary, it's Windows only. I don't like it. The reason I don't like it is because when I'm trying to learn how to do these things, the answer frequently is just open up ArcGIS and do it there. And first of all, I'm not using Windows. I'm not interested in spending that money. I'm not a full-time GIS person. But additionally, I'm trying to build server-based software that does this stuff, and I can't rely on somebody having to open everything up in a desktop piece of software every single time. So that makes life very difficult. And a lot of the things I'm going to be talking about here are how to basically get around those requirements. And one of the problems with that is why it took so long for me to learn all this stuff. Because most of the learning resources and most of the people doing this day to day are doing it in ArcGIS, which A, is so easy that you don't need to learn a lot of things, but B, means that there's very few resources outside of the ArcGIS world for learning this kind of stuff. Okay, PostGIS is a set of extensions for Postgres, and they basically make it possible, and have since 2001, for Postgres to be really, really high powered in terms of doing geospatial stuff. WKT is a text format for representing geometry. You'll see examples later. WKB is a binary format, which is more what actually ends up getting stored in your database. And then GeoJSON is a more modern kind of version of WKT, but it's JSON, so it's easier for us to read and it's easier for us to code against in PHP and JavaScript. Take a breath. All right, let's build an app. So because I can't actually show you everything I built with my clients thing, we're going to build a lot of similar contexts in something else. And so I thought, well, what would be a good context for me to be able to make something up that has lots of geospatial stuff and combines it with something I love and can laugh while I'm making? And so I combined 2 of my greatest loves together into one sample application for us. And those loves are programming and avocado toast, because I am a millennial after all. This is, honestly, we talk about the fact that the number of people who are there, you know, not seeing them is the difficult part, but it's not hearing you laugh or not laugh when I make a joke that's actually the worst part for me. So it's the laugh track that I need. I need Ian there with a little button that just lets him like do a fake laugh track. So I can... Yes, that's what I needed. Perfect. Okay, so we're going to start building the website with very simple points. No complex OpenGIS stuff, anything like that. Latitudes, longitudes, and that's it. Most of the stuff I'm going to show you here is not relying on packages, and a lot of the stuff I'm going to show you here isn't relying on Laravel. We will get later into things that make some of this stuff easier, but you're not going to know how to use them unless you understand how this works. And so I want to show you how it works. So simplest thing, create a database table, make double for latitude, double for longitude. Of course, you'd also have your timestamps here, but I deleted them for space. So what we're imagining here is we've got this hot new restaurant startup, and we're going to have a new entry in this table for every single one of our individual restaurants. It's got a latitude, it's got a longitude, it's got a name. It might be the Gainesville one, or the downtown Gainesville one, or the West Gainesville one, or whatever else. And then you want to put those points in a map. And you don't need anything other than a little bit of JavaScript in the Google Maps library. And you could use some of the library, but I'm going to use Google Maps for everything else. And then that database table and something to get that database table into the shape of this JSON. We'll be using Vue for the rest of this because the app we built is in Vue. Is just much easier for me to use Vue. But I just want to show that you don't need Vue. Like literally this code right here says, given a JSON list of restaurants with basically latitude, longitude, and name, spin up a map, and you can set parameters on the map, how big it is, what zoom level, kind of stuff. But simplest thing is you spin up a map, throw it in that document, that ID with the that element with the ID of map, and then for each restaurant, add a new marker, and the marker basically has the latitude and the longitude, and that's it. This one doesn't even use the name, but some later ones do. And so you just get like one of those little bubble points on it for each of them. Same thing on View 2 Google Maps. You do a Gmap map component, a Gmap marker component, and for each over the restaurants for a marker, and you get a new marker for every restaurant, and it's got the latitude and longitude it needs already set when it passes the thing in, and you're good to go. And this is what it ends up looking like. This is our Albert's Avocado Toast website, where for every single restaurant in our database, we get a little bubble, doesn't do anything, just throws them all on the map real quick. That's it. Now the problem is, this thing started in Gainesville, but what if you don't live in Gainesville? You don't even know where they are, and you have to zoom out a whole bunch of times to find it. So let's add one more thing before we dive into more complicated database work, which is browser geolocation. So have you ever seen one of those things where it says blah, blah, blah wants to know your location? It's extraordinarily simple for you to add that. Now they could say no, and you got to add more code to handle that, which I did not put here, again, for space and time. But assuming that they say yes, this is all you got to do. You say navigator.geolocation.getCurrentPosition, and then pass it a closure or callback or anonymous function or whatever you want to call it that basically says, when I get that position back from them, do this with it. And as you can see, it's got a coords thing on it that has a latitude and longitude. So what I did is I just set up a center object or a center property that Vue uses to basically sync up with the center of the map. And then that center gets set by the browser, and then that's it. The moment they say yes, it'll zoom, center right in wherever they are, and you're good to go. So let's talk about the next most common and simplest thing we can possibly do with this geospatial data that we're doing. Again, this is before we're doing more complex database structures. What if they said, I want to show, after I geolocate, I want to show the 5 closest restaurants down at the bottom. It's not just good enough that I show you a map. I want to be able to say, based on where you are right now, here's your 5 closest. So first what we're going to do is we're going to add a call to this non-existent yet made-up API endpoint that's /API/restaurant/near. Just kind of made it up. Pass in our latitude and longitude, and we need to figure out how to basically say, give me the restaurants near that. So again, just thinking ahead, we'll probably make a scope called closest to or near and pass in a latitude or longitude, and then we'll sort by that or something, not totally sure yet. So let's move on to the next slides and take a look. So before we actually write that backend code, we're just going to update that exact same geolocation snippet that we just did. And just below it, but below where we're setting the snippet, remember at this point, we now have that position. We're going to make that call to API/restaurant/near. We're going to pass in the latitude and longitude we got from the browser. And then we're going to set the close restaurants property to the response that comes back from there. So I'm sure you can imagine basically somewhere we're basically end up saying, return restaurant closest to latitude and longitude, limit 5, and get. This is great. Now all we have to do is build that scope. So somehow we're gonna have to figure out some weird math, figuring out the latitude and the longitude of the restaurant and the person. And we don't really know how to do those calculations. And maybe we can do some kind of mathy stuff, but first thing my head goes to is just taking their core location and adding a mile out and seeing, oh, is it there? It's actually in meters, so it would be a kilometer out. Is it there? Nope. Okay, go further and further. That's obviously not going to be the case. Just don't even do it. It's not worth your time. There's magic for this. And remember, I talked about Logan having given us this magical blog post. This is where this comes in. He wrote a blog post in the Titan blog called Calculating Distance Using MySQL. And what you can see here is there's this whole new class of things we have available to us in MySQL that have been there for years, but we didn't know about it, I think since 5.5, and then they got a little bit better in 5.6. And they're st underscore whatever. So this particular one, the simplest one, is give me the distance between 2 points on a map. And you can create a point by passing in a longitude and latitude. So if you were to just basically say, select ST distance sphere between point latitude and longitude 1 and point latitude and longitude 2, without even connecting to the database, just select that, it'll just tell you the distance. It's smart enough to be able to basically do like an earthy projection and give you a very, very, very accurate, not perfect, but close enough distance between the two. And so there's all sorts of interesting things we can do just by passing some hand-provided values and some non-hand provided values into this ST distance sphere thing here. So what you can see here is that he's ordering by basically that distance ascending, which means give me the one that's closest and the one that's next closest and the one that's next closest to this latitude and longitude. So by passing the browser geolocated latitude and longitude in, you now have the ability to say order by how close it is to my latitude and longitude. And that's it. You now have that fully functional scope. And this thing right here with the 5 closest restaurants now calls this thing right here that calls the closest to scope. And then we've got a fully functioning closest to scope right here. And it's it. It works, and we can see the 5 closest restaurants. And I'll show the UI for that a little bit later. But that's completely functional. We have to do nothing else, no complexity. It's just working today. Another cool thing you can do with this is invert your logic. And instead of saying closest to me, what if you said, I want to do a delivery radius? Every restaurant gets to define its delivery radius. And I want to find which restaurants I'm within the delivery radius of, which restaurant delivers to me. So again, you could do a relatively basic mathy way of doing this. And you say, well, the delivery radius of this restaurant is 1 mile. So what if I just draw a square from that restaurant that's a half mile up, half mile right, half mile down, half mile over? That's pretty easy to do with the math. But the problem is that's not actually a mile, because if you go out to the corner, it's going to be a mile plus a little bit. Thankfully, with Logan's magic math that he saw in that blog post, you can do that exact same thing. You can use that ST distance sphere, and you can actually compare it against a property on the restaurant. So you can say, again, where raw, ST distance sphere, you can compare the distance between the restaurant and the provided latitude and longitude, and then you can say, and remember the last one was order by raw. This one's where raw, and we're saying where it's underneath this delivery max, or this restaurant's delivery max range. And that modifier right there just converts meters to miles. And so we stored the delivery max range in miles in this particular one. So now we can say, for my latitude and longitude, assuming that every single restaurant were to have a longitude, a latitude, and a delivery max range, I now can figure out which of them I'm actually within the range of. That's it. Super easy. Okay. Take a pause, take a breathe. We're halfway through the slides already. I'm trying to move fast in this one. I should probably talk more slowly, but I'm trying to experiment, giving lots of times for questions at the end. So we are about to enter into the point where we're actually going to do more complicated database stuff, but I want you to just look back and reflect and say, with no changes to my database structure, with no new complicated geometry fields and all this kind of wonky stuff Matt's about to teach me about, I can already do an incredible amount of stuff that I may not have known that I could do before. What we go on to in the future now is a little bit more complicated, but it is still all possible with the databases you use every day. So, like I mentioned before, Postgres has classically been the answer people reach for when they do geospatial because it has PostGIS. And PostGIS or PostGIS, I've never heard anybody say it out loud, has been doing this stuff since 2001, and MySQL has been doing it for terribly. But as of 5.5, and then especially as of 5.6 in MySQL, you basically have the ability to do, I don't know the exact percentage, but of the things I've tried, somewhere between 60 and 80% of the things that PostGIS can do, you can do in MySQL just natively with no special add-ons or anything like that. Now, granted, if you're going to do something that's very complicated in this way, you should probably consider Postgres. But I know that there are a lot of people for whom that's either overwhelming or impossible. And you can do a lot with MySQL. So we're going to do all this in MySQL, but everything that we do going forward from here will also be possible in Postgres. And then there's also some more that you can do. So a real quick reminder, and this is because this will actually come up in the space of what you're doing, there's a difference between a geography and a geometry. And generally the simplified version of this is basically geometry is on a flat plane, geography is on the earth. That's the biggest difference. And they actually differentiate against those in the world of MySQL and Postgres add-ons. And so you can try the one that looks like it might work well, and it says you provided a geography to a geometry function, it's not going to work. So there's a little bit of a dance there. So just knowing that those two are distinct within the database post-spatial work or geospatial world will hopefully save you a little bit of pain. There's one more complicated thing that I need to teach you about, again, before we get back into the code, which is the SRID, and that's the spatial reference identifier. So there are spatial reference systems, which are basically how you identify the shape and the projection of the specific coordinate set that you're working on. So the simplest way to think about it is the difference between drawing geometry in math class on a flat piece of paper versus drawing geographies on a globe. And if you ever heard of like the Mercator or Mercator projection, what you're aware of is that there's different ways to take the space of the globe and try to put it onto a flat screen. Because at some point we need to have flat maps and flat screens, but the world is not flat. And so you've seen all those different shapes where in Google Maps it looks like it's full, but in some of the other ones it looks like there's like a series of like camel humps and stuff like that. These are all different ways of trying to, as accurately and conveniently as possible, convert one coordinate system that's a different shape to a different coordinate system. And so these spatial references are essentially different ways of thinking about how to do those sorts of projections. The ID is just the unique number, you know, it's literally just a number that, like an integer, that identifies the specific SR that you're in. MySQL supports over 5,000 of them, but there's three most common that I want you to know about. By default, MySQL uses SRID 0, which is not really an SR at all. It just means flat. There's no context, there's no knowledge. What you say is what you say and kind of shrug. That's it. It's fine for geometry, no good for geography, which is why all my code that you see in the future will always specify an SRID. You'll see 4326 everywhere through the code samples that I show you. The most common SR is has the SRID of 4326. And this is, in the non-SRID world, it's called WGS84. And if you just go Google or Wikipedia WGS84, you'll hear about the whole history of this. There was a WGS 60-something and a 70-something. Those are like 1960-something, 1970-something. Came out in 84 and become the most common one. It got updated in the 2000s, but it's still one of the most common and best respected ones, and it's what GPSs use. So this is the most common one. However, it's not what Google Maps and Bing use. So if you're looking at those sorts of online maps, you're actually going to want 3857. What you'll notice through these examples is that I'm doing all my work in 4326, and then I'm putting it on a Google map, which is 3857. Part of it is because it just, the very, very, very tiny nuances of accuracy don't matter that much in the context that I'm in. But one of them is also just, and I should have said this earlier, I'm new to this. I had never done any of this stuff ever before prior to October. And there's probably at least a few people listening here who are like total pros, who are like face palming at everything I do. That's totally fine. Teach me things. You know, I'm one of these things like, I learned this, come along and we'll learn from other people together. But I would say that my practical experience of using SRID 4326 database stuff and putting it on an SRID 3857 map has caused me zero problems so far in my storied career of 3 months. So that's it about SRIDs. So we're going to move on to the next level of coolness and complexity that we can do that we weren't able to do before. So remember, before, all we did was three things. We did points on a map. We did using math to basically say plus or minus on the latitude and the longitude. And then we did radiuses using that ST distance sphere. How many meters away am I? I'm going to tell you a real quick story about another client. So we had a client who basically needed at any given moment to know, based on the latitude and longitude, which of our regions are you in, which was exactly what I described before. A totally reasonable thing. Lots of people need to do it. One of the problems they're running into is if you are anywhere near Mexico, for example, in Texas or Louisiana, it's going to say that you're in Mexico even though you're not, because just like we had been doing prior, they're showing you the top bound, the left bound, the right bound, the bottom bound, which is a very reasonable thing to do because that's all we really know how to do math-wise. The problem is if somebody's in San Antonio and trying to find, you know, which region they're within, they're getting Mexico, which is certainly not the case. And so what they wanted, which I was like, I can do this now, was the ability to draw a polygon. And if you've ever played video games, you know, polygons, it's basically a series of points that form a line and the lines meet up together and they meet up at the end. And so you get some kind of shape. So really, when I talk about polygons, just think about closed shape. That's really all we're talking about. So imagine the possibility that you can store something shaped like this in your database and ask those same questions of it. Which regions am I within when I'm in San Antonio? And for the database to be able to tell you, not Mexico, I know that. That's what we're doing here. That's the next step. So as of MySQL 5.5 and Postgres, since PostGIS has existed, there's a new field type in the actual SQL called geometry. It's literally just the word geometry. And so that geometry can store things of different shapes. You can have a point, so that's latitude, longitude, but you can also have like a polygon, which is more like the Mexico thing. We also have a new key type, which allows you to key things by, spatialness or whatever. So we update our restaurants table to now have a location and a spatial key, and I'll show you more about why in just a second. Here's a couple examples of what it looks like. And remember before I talked to you about WKT and WKB, well-known text and well-known binary. The most important thing for you to know is that as humans, it's easiest for us to learn when we're dealing with a SQL database, well-known text, which is this, point, comma, lat, comma, long, SRID. Quick note, sometimes it'll look like that, and then sometimes it'll be point, lat, space, long, and then even sometimes I think it's point, long, space, lat. So before you do anything, like I can't even tell you that that's definitively right in which context. So before you're doing anything with these lat and long points, go look it up for the specific context you're working in. It's a little bit wonky and wild, and that might even be backwards. I'm just going to be super honest about that. But in general, that's what a point looks like in well-known text. That's what a polygon looks like in well-known text. The problem is that's not actually what they're stored like in the database. They're stored as well-known binary, which takes this and converts it to something that you're not able to read, and I'll show you that a little bit later. But at least for now, let's know that this is the case. So we're going to create a new table that has polygons in it. Let's imagine that as our restaurant gets bigger, we need service areas and a service region. And a service region is something along the lines of, we've got a central warehouse somewhere that is responsible for delivering our key salsa to all of our restaurants. And so that one warehouse makes it and stores it and delivers it out to all of them. And so each of those service regions basically has a central warehouse that services all of them. At any given moment, we might need to know which service region is a given restaurant in. So we create this new table, service regions. It's got a name, an ID, and it's got a shape, just like last time. But notice I named this one shape instead of location, which triggers to my brain, this is supposed to be a polygon, not a point. But in the end, it looks the same. It's a geometry. It's got a spatial key. And down here at the bottom, I know it's a little bit small for some of you, but you can see what entries. This top table screenshot is what an entry looks like into the service regions. And so you can see that, at least in SQL Pro, I don't think this is the case in Tables Plus, which is why I did all these in SQL Pro, you actually get to see the well-known text version of it, even though in the database it's actually being stored as binary. SQL Pro is helping me out by translating it to something I can read. And so that service region has a polygon as one of its things that describes how that service region is shaped. Not just how it's shaped, but where it is on a map. And then you can see from the restaurants database, once I added that geometry column, we now get that new one called location, and it's basically a point with the 4326 SRID that references the exact same latitude and longitude as those latitude and longitude columns. Okay. So we've got some new methods available to us. And remember, when I said we're talking about all these geospatial methods, it's st underscore something. There's a ton of them. These are the 4 that I've used the most, but there's a lot more. St contains, you pass it 2 values and say, does the first value contain the second value? It's most common to pass the first value as a shape, like a polygon, and the second value as a point. Is this point, does this shape contain this point? But you could also say, does this shape contain this other shape? St within is the exact opposite. Is this first value within the second value? It's just a convenience thing, sugar. In the end, they're doing the same thing. St intersects says, do these 2 shapes intersect at all? And they could be exactly the same or not exactly the same as long as they intersect. There's also another one called st overlaps that says, do they overlap and aren't the same? So it's almost exactly the same. And then st touches says, do they butt up against each other without actually overlapping? And so that's how you can know whether there's kind of like shared coverage or just if they kind of perfectly line up with each other. And so we'll see some of these in our examples and some of them we won't. So here's 2 really common patterns. The first one's pretty easy to understand. Select star from service regions where st contains shape. And so that's the shape column on the service region. So we're saying where the shape of the service region contains, and what's our second parameter? It's st point from text, point, latitude, longitude, or longitude, latitude, SRID. So we've got a couple new things we're learning here. One of them is that we can't just pass in the point, blah, 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 blah. Sometimes when we're working with well-known text, because this is expecting binary, we actually have to do st point from text here to convert it. Someone who knows this really well could actually point out the fact that there's a trick that I could do to not have to use st point from text, and it's that thing I told you about where there's multiple different ways to use point. But I want you to be able to see this. Just ignore that. If you're a super smart person, do it your way. But I want you to see that a lot of times when a human being is writing code to be consumed by SQL in geospatial stuff, you're going to write it in well-known text, and then you're going to pass it into one of these st point from text, stgeom from text, or whatever things that converts well-known text into binary for SQL to work with. So when it says select star from service regions where st contains shape, that shape, as it's parsed by SQL, is binary. It is not this beautiful, well-known text that I'm reading as I look at it in SQL Pro. We could also do a very similar thing, which is what I ended up having to do in our client thing. It says, if I want to link every single one of my, oh, you know what, this shortcut was assuming there was going to be a table that I ended up deleting later. But basically what you're going to do is you can say, if I have two different tables, and I want to not just have to do these lookups every time about which one's within which, but I actually want to set like a foreign key ID on which one's within which. You can do these types of things where you're basically updating the table that should have a foreign key ID. You're interjoining it against another table based on the results of this st-intersects query and say, all right, if these two are in the same spot, that means they're connected. Run this query once and then foreign key ID them, using a traditional foreign key ID. And then now we don't have to do the geospatial query ever again in the future. So you can do these more complicated and sometimes more processor intensive geospatial queries once and then say, great, I got the answer. Now I can link them with an actual foreign key ID and then move on with my life. So how do we actually get data into the system? Well, like I said, the most common thing is going to be text to geometry conversion. It's going to be us writing well-known text and then updating it using these things that convert well-known text into binary. Again, there's a lot of other ways to do this that are a little bit more 201, but this is the simplest possible way for your average programmer to work on it like this. So this is what I'm going to teach you about. So there's st point from text, which basically says, take the well-known text and convert it to a geometry point in binary. There's geom from text, which does the same thing, but it's more assuming it's going to be a polygon. And then there's geom from GeoJSON, which we'll talk about in a second. So here's a quick example of what GeoJSON looks like. And again, don't worry, I'm going to tell you more about GeoJSON in a second, but it's the same kind of idea. You're actually passing in the data in some structured form that's not binary, because writing binary on our side is hard. And then it does the conversion and stores it as binary. And that makes all the future work faster, because SQL doesn't have to be converting it in and out of binary and well-known text every single time. It could just do binary against binary conversions. So if you're storing these types of files locally, there's a few most common ways to store this type of data. And the first one is a shape file. And it's not actually a file. It's more like a directory of somewhere between 5 and 15 files. Every single one of those directories has to have a .shp, a .shx, and a .dbf file. But you'll often also see other things like .xml and quite a few other things. And it's one of those ones where you just kind of say, just keep them all in there and then point the tool at it and hope the tool gets everything it needs out of them and have the tool convert it to something I want to work with. Shape files are pretty common, although they're a little bit old. They're designed by ESRI, who are the people who make ArcGIS, which is that expensive proprietary Windows tool that I complained about. And so for me, it feels a little bit like the spatial equivalent of .xlsx. It's robust, it's a little bit overwhelming, it's proprietary but openish, and it's provided by kind of like the people who have all the money and the power. So I'm caricaturing that a little bit for sure, but that's how it's felt like to me. And then there's this alternative called GeoJSON, which is created by an internet working group instead of an existing shadowy monolithic organization. It's open, it's human readable, it's easy to convert to and from with lots of tools, and most modern tools can use GeoJSON directly. And I mean, you can see these examples of GeoJSON directly from a Wikipedia article or something like that. Type point coordinates, X, Y. Type line string coordinates, 0.1, 0.2, 0.3. Type polygon coordinates, blah, blah. And you could see GeoJSON works for geometry, not just for geography. The geo is kind of sometimes tricks you because you're like geography, but geometry has a geo too. But it's really helpful for us when we're doing this kind of stuff and we want a modern format that's human readable, human generatable, easy to read and parse and write with PHP and JavaScript, and works with everything else. So first thing I did with this client project was take all their shape files and convert them all to GeoJSON and store them that way. And then finally, sometimes you're going to use stuff like CSV or other simpler structured formats. It's the simplest if you've basically got a list of latitudes and longitudes. So one of the things I also ended up doing in the latest project is convert all the restaurants, the restaurant equivalent, into the name, the latitude, and the longitude in a CSV, and then build a whole bunch of tooling for processing that. If you do find yourself needing to convert your file formats, there's something called the Geospatial Spatial Data Abstraction Library, which you can install with Homebrew. And it gives you a tool called OGR to OGR that can convert between all the formats. And as you're converting, it actually can even modify the shape of the properties. And one thing I had noted to you was that shape files and GeoJSON files can have properties. So you don't just get the latitude and longitude, you can get the name, you can get all sorts of other properties as if it were like a database entry. And so one thing you can do here is you can use an actual SQL syntax to say, well, the name field on the shape file was super duper name, and I want the name to just be the word, and the letters NAME, name. Well, you can perform that conversion before you get into this GeoJSON file, which is really helpful because these files can be hundreds of megabytes if you've got a lot of data in there. So it's not just one of those things where like, oh yeah, I'll just slap it open in Sublime Text or PHP and do a quick, batch rename on that property or something like that. Especially if you're trying to set up chains that you can regularly rerun to do these conversions, being able to do it in a tool with a relatively complex and powerful syntax like this is actually really helpful. All right, let's talk about retrieving data. So we talked about how to do comparisons against the data. We talked about how to get the data in. We talked about how to put some of the data on a map, but we haven't talked much about how to get the data out. So like I said, the data is stored as binary. And just like we have methods that allow us to convert our well-known text to binary, we can do the opposite. And you notice this right here. You can see where I said DB table service regions get. It's a little bit hard to read in this Tinker shell. And when you get one of those back, that shape field is just binary, not human readable, very difficult to understand. But if you select st underscore as text and then the name of the field, or it doesn't have to be the name of the field, it could be some manual well-known binary that you generated on your own, that st as text converts the binary form back into this well-known text human readable form. It turns out the humans are bad at reading binary, so this is really helpful for us. So you do have the ability in SQL to make these conversions back. One of the things you notice here is that while it's really convenient for me to read, it's not as if my PHP code is going to be reading that syntax. We'll talk a little bit more about that later. But just so you know, when you select anything for the first time, you go, wait a minute, in SQL Pro, it looked really readable. Now it's not. Well, this is why. Here's another pro tip. Anytime you convert one of these entities to JSON, it's going to basically crap out because geometry does not convert to JSON really well. So you definitely want to go add your geometry field to the hidden property in your Eloquent model so that anytime you send it out to JSON, it doesn't get sent out. We don't want to deal with that. One thing you're really going to want to do if you're working with this is getting much more familiar with the query builder. We can work with Eloquent. You'll see me working with Eloquent. You have already. But in the end, I'm doing a lot of query builder chaining onto these Eloquent models. And so you want to get familiar most with raw, because raw is what you do when you got to do stuff that's not provided out of the box with Laravel and Eloquent. For example, all this geospatial stuff. And we have a lot of things: order by raw, where raw, select raw, or whatever else you want, and just but instead of passing in the string, you pass in db : raw and then the string. And so Laravel gives you a lot of really convenient tools for doing what you want without Laravel trying to validate and change and everything like that. So here's a couple examples. This first one you saw up there that I wrote in SQL says select star from service regions where st contains shape and then that. So what we're basically saying is find all the service regions that whose shape contains this one point. And so what I did is instead on the Eloquent model service region, I said where raw, and then I basically pass in that exact same thing. Somebody might be looking at that and saying, can't you use the PDO parameter binding with the question marks? For some reason, I couldn't get that to work. I bet you it's possible, and I just had something typed wrong. For now, I used sprintf to get the exact same concept as a parameter binding, but a little bit less safe. So if somebody's able to fix that, put it in the chat or hit me up on Twitter or something like that and tell me why. But still, this is enough. Where raw allows me to do whatever I want, and I can use sprintf to at least make it a little bit cleaner. One of the interesting things you can do here is you can export your data to GeoJSON. And remember how I talked about GeoJSON being this really powerful tool that you basically can use in and out of a lot of other things? Well, Google Maps can read GeoJSON, so can a lot of other things. And so one of the things you might choose to do is not just pulling this data as Eloquent results that you pass into a blade view that you pass off to view or something like that, but actually just having an endpoint that is GeoJSON. And as you can see here, all I'm doing is just taking all my restaurants, I'm mapping over them, and for each of them, I'm creating a GeoJSON feature. And most GeoJSON responses are either a feature or a feature collection. So this one, I'm creating a whole bunch of features and then slapping them in a feature collection. And for each feature, I basically say, It's what type is it? It's a feature. What's its geometry information? This should be really familiar based on what we looked at earlier. It's a point type, and its coordinates are 1 point, latitude and longitude. That's it. And then you can add all the properties you want. GeoJSON doesn't care about your properties. It just makes them available to the consumers. And then I take all of those, and then I wrap them up with a feature collection and return it as JSON. Good to go. And this is consumable by a lot of things. I'll show you how to consume it with Google Maps later, but there's other things that can consume this. So this is really powerful. Plus, it's treating it as if it's a file. You can cache the heck out of it, both on the front end with with your expiration layer and with something like Varnish. But you can also do a whole bunch of crazy caching here. So I want to show you, and this is actually going to be the last thing we do because there's so much more, but I put up a repo with quite a few things I'm doing here so you can dig into it more, and I'll have a few links at the end. But the last thing that I have time for is I want to show you a few cool things that we're able to do with Google Maps that once I got the basics working, I had to answer harder questions. And so I kind of said, okay, how do I answer this one question? And when you get to the hardest questions in programming, that's the time you're most common to say, you know what, I remember that one thing I saw 3 years ago. And the more experienced programmers have more to bring in those contexts because they have experience. And so this is definitely the place where I was like, I don't know, let me go figure out how to Google this thing, And so that was quite a bit of this. So I just want to share a couple of the tricks that I found. Also note, a lot of these are probably possible with Mapbox and others, but I'm most familiar with Google Maps, and so that's what I use for all of these. So the first problem I ran into was the entities for the system we built. There's 300,000 entities. And your database isn't going to be spitting out 300,000 entities for you very well. Your PHP isn't going to love 300,000 entities. Google Maps is not going to let your browser load 300,000 entities. We had a problem. So I had to somehow load a subset. So how do you figure out which subset you're going to load? What I was able to do is figure out that Google Maps at least makes it really easy for any time the bounds of your map changes. So if you zoom in, if you zoom out, if you pan around, and also in the initial load, it sends an event called the bounds changed. And so what you can see on this right side here was I basically said, every time those bounds change, grab the bounds, so it's going to be a top, bottom, left, and right coordinate, and then pass it into this new API endpoint called API/restaurant/within. You pass those 4 query parameters, so top, bottom, left, right, and then I created a within endpoint point, which turned out to be one of the simplest things I wrote in this whole project. You can see it there. Select these things where latitude is between bottom and top, and where longitude is between left and right. That's it. Easy, done. And so I went from getting 300,000 records to getting, hundreds of records. And then I was also able to lock the zoom. So you can zoom in, but you can't zoom out past a certain point. And so you could never get more records you can actually fit on the screen. Really powerful, really easy. There's so many other things that are available to you as well. Or even then we were having some caching issues. I wanted it to be a little faster, and we're passing a whole ton of data down with this whole JSON that we sent in. And so I said, wait a minute, I only need a whole ton of this data when I actually click on the map and it does a little pop-up. Why don't we just send a simple list of data, and then when you click on the map, it sends an AJAX request out. And I had quite a few conversations with Titanites in this, so I can't thank the specific person that helped me, but I was thinking through that, and some folks were really helpful. So we end up sending in just the latitude, longitude, and the name as the initial list, which we're caching super heavily. But then, as you can see in here, in the info window, basically it's got a little loading sign, and then the moment this info window pops up, it makes a request to get the more detailed information just about this one point, this one restaurant, and then it saves it in, and so the thing loads really quickly. And the last cool thing that I was able to do is you can actually just straight load a GeoJSON file and just have it show up on your map. Now, if you're doing points, you're not going to have the same control over those points that you do if you do them the way we're doing here. You're probably not going to want to do that. But one of the things I could do is put polygons on in a really interesting way. And so this is not the actual service regions, but I basically grabbed all the Florida counties as a GeoJSON off the internet real quick and just threw it into that, and bam, the counties are shown. And the amount of power you have with working with these kind of more consistent modern standards that everything else can work with is really impressive. So, and there's a lot more you can do there. So look how far we've come. Albert's Avocado Toast website. Now you can find a restaurant. You can see all the restaurants in there. You can see your 5 newest restaurants, and you can probably build quite a few other complicated things that I described, like, am I within the delivery area or whatever else. And as you can see here, I put it up in a repo, github.com/Matt/Stauffer/Albert's Avocado Toast. And I actually put issues in there and said, hey, if you want me to add some of these things I talked about in the talk to this repo, let me know. And then basically this was, I'm just super busy and I was going to build this thing out to be super robust, and I just ran out of time. So if someone's like, man, I really want to see how to do that one thing, just go hit me up in the issue there, and I will build it out when I have a little bit of more free time. So way more interesting stuff to talk about, but that's for my 45 minutes. I want to leave a little bit of time for questions if I think it's appropriate. But a few last notes and links. You probably, if you've been around, you know about Geocodio. They're Laravel folks, friends of the community, and they make it really easy for you to basically look up geocoding information with a pretty affordable and easy to use API. Google Maps has a more robust platform, but it's Google. So if you can get it done with Geocodio, do it with them first, and if you can't, do it with Google Maps. There's also some great documentation about MySQL spatial types, and there's some new things that are added in 8.0. So when you move over to MySQL 8.0, you're going to get even more things available to you. You can do some of these things more easily, but more limited with Algolia. So if you need to do some of the simplest searchy type things, just show me the things near a certain area or wherever else, Algolia's got some really powerful stuff there. Again, it's pricier than hosting yourself, but as with Algolia, it's also faster and easier. So if you want to do some of the more limited subsets of just searching, check out the Scotch.io tutorial. It's really good stuff. It gets you up and running really quickly. And then finally, Bryce Hartman wrote a post that gives you some of these same basic intro stuff, but with a little bit more depth and a few of the pieces I didn't go as deep a depth. And it's one definitely worth reading. A few more links. There's a package for doing spatial with MySQL or PostGIS in Laravel. This is going to make some of the things I just described to you less work. For example, as you can see here in these screenshots, you actually have a polygon class and a line string class and a point class. And so those classes sometimes can make it much easier for you to be able to build some of this stuff. Whereas, like I mentioned, WKT is easy to read, but it's not always easy to parse with PHP. This package and these packages can make some of those things a little bit easier for you. And there's also a tool called GeoPHP, which is not a Laravel tool. It's not even a MySQL tool. It's actually just a direct PHP tool. And if you want to do some of these conversions that MySQL is doing in the MySQL side, but you want to do it on your side, it can do things like given a polygon, give you the area or give you the centroid point, which is like a point where if you draw 1,000,000 equal lines in it, what would be the point where they all cross? What's the X of the centroid, the Y of the centroid, or you can even convert things in and out of some binary stuff. So this might be a useful tool for you at times. And then finally, if you want to be kind of figuring out, are my actual maps correct? Wicket is an online one that you can paste some things into. There's an Electron app that my friend built called GeoJSON, and you just download it and upload a GeoJSON file into it, and it puts it on a Mapbox map. And then also SQL Pro, not only does it convert these things to WKT when you're previewing it, but if you hover over that polygon, it actually shows you the shape of the polygon. It's not showing you in a map, so it's not perfect, but it at least can give you a little bit of debugging helpfulness there. So that's the end. Obviously, it's just the beginning, right? This isn't even everything I know, and I'm only a couple months in. There's so much more to learn. But for now, I'm going to put speaker deck links online. I think it's going to be mattstauffer.com/talks. And then this repo for Albert's Avocado Toast. I kind of made Albert's Avocado Toast the repo just for taking screenshots, but then I was like, you know what? Why don't I upload it and let other people see it? And I can make it more robust if people want. And of course, I think I have a little bit more time, and if I do, then Ian will ask me questions. But if I don't have more time, I'll go in and answer questions in the thing right now. So I hope this is helpful to you. I hope you get inspired, and thank you all so much for your time.
Awesome job.
Thanks, man.
Really interesting. Yeah, I could imagine having just a couple months to dig into that must have been a nice sort of change from the regular web developer.
Yeah, it really was.
Activity.
Yeah.
So you hit actually a number of the questions that came up you were kind of touching on. There's one in there that I don't think you touched on unless I missed it, which was storing these latitude and longitude in floats, or like what do you store them in?
Yeah, right now I use double. I got to be honest. Every time I deal with the double float, blah 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 blah, all that drama, I learn it enough to solve it for a particular problem, then forget it again.
Right.
But remember, there's some serious accuracy issues with there. Somebody smarter than me is going to have to answer that one. But what I do remember is I ended up setting on double, and I didn't pass in the you know, when you're making a column, you do the parens that say the length. I didn't do that. So whatever the default length for double is has been serving me fine. But that's not a canonical answer. That's just what I got right now. So
like if you're shooting missiles, you might not want to do it that way.
Yeah, exactly.
But for delivery radius, it might be okay.
It's doing fine. Yeah.
All right. Very good, man. Well, appreciate it. Great job.
Thank you.
And we'll see you next time, I'm sure.
All right.